So hello world, welcome to this coding challenge and tutorial where I will be coding a lightning simulation with JavaScript. So if you like this kind of content and you would like to see more in future, hit the thumbs up button and please consider subscribing to this channel. And also if you have any suggestions for content that you'd like to see me do in future or questions, feel free to leave them down in the comments. So wait, before we get to the tutorial, there's a slight issue with my VS Code. I'm not sure if it might bring up issues later. For some reason, I can't select anything on a single line. I have to select multiple lines. I'm not sure why that is, but if you have any clues as to how I might fix this, please leave them down in the comments. So, let's get to the tutorial. So what I have here is a blank canvas project with my HTML, CSS and JavaScript file. And what I'll do first is to put in the HTML template. Then I'll link my CSS and link my JavaScript, add a canvas item first to the script. And then I'll link my JavaScript. What I'm using is called Emmet in VS Code. It really helps you to create HTML faster, so you can look that up, or I might make a tutorial in future, so stick for it. And then so we're done with the HTML. Let's call this lightning. Then we can move to the CSS. Let's select the body element here, and then we'll give it a width of 100% and a height of 100 VH so that it fills the entire screen. Then we'll give it a padding and a margin of 0 so that there's no weird border, there's no white border at the edge of the canvas when we create it. Then we'll give it an overflow hidden so that the canvas doesn't overflow through the screen, but it actually just fills everything. And then we'll give it a background color of slightly black so that we can see the lightning. Then next we'll select the canvas and we'll make it fill the entire height and width of the body by setting everything to 100%. Now we can just close the CSS and the HTML also if you want, because you're not really going to use them anymore, and we'll move to the JavaScript. So in the JavaScript, what we're going to do first is to select the canvas. Then I'll use document query selector because I usually like this one, but you can use document get element by ID or any other method if you want. Then next I'll select its context studio, which is like the pen we are going to use to render everything on the screen. Afterwards, we'll set the number of pixels in the width of the canvas equal to the number of pixels in the width of the screen, and we'll do the same thing for the height. Afterwards, we're done setting up the initial whatever. Before we move on, I will take the pen and set its color to white. We'll set its color to white so that we can see everything, because if we don't do that, we're going to be drawing a black color on a black background, so we really won't see anything. Then apart from that, I will set the width of the lines it's going to be drawing to 2, and I'll set it to have let's do this later. Let's do that later. Let's just move on from here. So now once we made the pen white and given it a width of 2, we are going to create a function which we are going to be using to randomize the values of the lightning bolt. So we'll call this get random integer, and we'll be using a minimum value and a maximum value, for example 0 and 10, and then we're going to get any numbers from 0 to 10, including 0 and 10. So you might get 0, you might get 10, or anything in between. So we're going to return math.flow times math.flow math.random times multiplied by max minus min plus 1 plus mean. That's how you generate a random value in between two different values in JavaScript. So Once we do that, we're going to create another function called generate, let's call it bolt. Yeah, generate lightning bolt, or let's generate lightning. Let's call it lightning, or whatever you want to call the function, as long as it does what it's supposed to do. So generate, we're going to call the functions that we can actually see everything we're doing. So first I'll check if everything is working, the CSS is linked, and then we can now move to the JavaScript. So yeah, let's call the function, and so yeah, the CSS is linked, and the canvas is black. So now what we will do is, in the generate lightning function, we will select the we'll create an object, let's call it lightning, and we'll give it a property x, which will be a random integer between -100 and canvas.width minus 100. So what this will do is, the reason I'm using 100 and -100 is, when we generate the lightning, for example, we really want to see most of it or part of it somewhere here. But if we generate it at the edge, let's say if the lightning is generated at the edge of the screen, we probably won't be able to see it, or we'll just see a very small portion of it. So when I use -100, 100 and canvas width minus 100, at least we'll be able to see a significant portion of it. So that's why I'm using 100 and -100. So we can now move on. So get a random integer between 100 and -100. Then we'll give the lightning bolt another property, let's call it y, and we'll give it a property length, which will be equal to a random integer between canvas.width divided by 2.5, let's say somewhere at the center, and also canvas.height. So what this will do is, when we generate a lightning bolt, it might have a different length. So it might be produced up to somewhere here. It might have a length of something in between this and something in between that. So the bolt might be this length, or this length, or this length, or this one, or this one, but it won't be too short or maybe too long. But yeah, you basically get the point. So that's what we're doing here when we are generating the length in between canvas.width divided by maybe 2.5, or anything you want. Most of these values are really my preference, or just a testing value. So you might play with this to see which values you'd like to see, or which values you like your bolts being produced from. Most of this, yeah. So we can now move on. So once we have that, we can test to see if what we are doing actually works. So let's move the pen to the lightning.x to lightning.y. Then we'll draw a line to not move to pen.line to. So this will trace a line to lightning.x to lightning.length. So we're going to draw a line to move the pen to where the lightning bolt has started. Then we'll trace it to the bottom of the bolt, and then we'll call pen.stroke, and hopefully it should work. I think this should be working. Not sure why that didn't work. It should be. Oh yes, I found the issue, and the issue is this. This should be stroke style, not stroke color, and then we should see everything. So now you can see we are drawing a line, and its length is something in between canvas.width divided by 2.5, canvas.height divide. No, oh yes, did I make an issue here? Yes, this should be canvas height. This should be the canvas height, and we should, yeah, it should be working properly now. Now you can see we have a line that appears randomly on the screen and has a various heights. So now we can make the line actually glow, so that because it's a lightning bolt. So we'll move here, then give it a pen dot shadow blur, and let's set it to maybe something like 20 or any value you would like. Then pen dot shadow color will be maybe something blue, red, whichever value you like. I'll just use 00A4 EB because I usually like this color. Now we'll see we have a glowing bolt. Not sure if it's very visible on your side, but we have a glowing line. So now we can actually move to getting the line to be all jagged. How we're going to do this is we're going to create a while loop. Then we're going to say while lightning.y is less than lightning.length, we're going to, so while the lightning's current position is less than the length it's supposed to be, we are going to lightning.x plus equal to generate lightning, no, not generate lightning, get random integer between, let's say, negative 10 and 10. And I'll be explaining what this is in a bit. Lightning.y plus equal to get random integer, let's say between -1 and let's say like 35. So what I'm doing here is basically we've gotten our first point of the bolt. So while the current position of the current y position of the bolt is less than the bolt's length, let's say the bolt's length was here, we are going to take the bolt and then we'll add a random y value and a random x value, maybe let's say -10 or +10 to it, and then we're going to draw a line from that, from our point to this point. Then maybe let's say that's okay. I think that was explained that well. Then while of course at this point the bolt isn't really at the bottom of its length, so we're going to move to the next point. So we're going to add a random y value. Let's say it may add let's say -1, so it might move slightly up here. Then we're going to add -10, so it will move the bolt, let's say somewhere here. So y -1, then -10, so it might move the bolt a little bit up. Then the next time it might move it, let's say somewhere down here. Then I guess you might get the explanation. So it comes to this point, then gets a random value, adds a random value to the y position, then it gets a random x position, and it moves the bolt there, then it moves it there, and then it moves it there until it reaches its length. That's how we're going to create the zigzag line, the jagged line. So let's move back to the code. So while the lightning bolt's current y position is less than the bolt's length, we are going to add a random value to its x position, and we're going to add a random value to its y position. Then we will draw a line to that position, lightning.x, lightning.y, and then we'll stroke, and then we'll stroke outside here so that there really isn't so that it doesn't stroke so many times and cause the program to hang. And then before we do that, we're actually going to do the pen.begin path, which will say we're drawing a new lightning bolt. Then after we've done everything we're going to do, then we're going to say pen.close path, and we'll have a complete lightning bolt. So now when we run this, we should see jagged lines. Let me move to another tab. My laptop really hangs at times. So when we do that, we should see a jagged line. And for some reason, it's not starting at the very top of the screen, and that is because I forgot to do one thing. before I move it there, I'm supposed to move the pen to the lightning bolt's beginning position. So I've moved the bolt to the pen to the bolt's beginning position before I generate everything. So it's going to start at the very top. Yeah. Now we have a beautiful lightning, but we're going to add the branches from here. You might try it by yourself and challenge yourself a bit, but I'm going to do it anyway. So once we do that, we've generated the line, the stroke, the stroke. What I'm going to do here is I'll create another function. Let's call it generate branch. Generate branch. And then I'll give it arguments x and y. Then in the while loop, we're going to get a random condition. Let's say if get random integer is between 0 and maybe let's say 5 is equal to 5. So there's a 6% chance, or 1/6% chance of this event occurring. We're going to generate a branch. I'll explain what this is. Now, I mean lightning.x, lightning.y. So there's a 1% 6 chance that a branch is going to be generated, and when it's generated, it's going to be generated at the current position of the bolt. So let's say the bolt is moving like this, and then we get that 1/6% chance. We're going to generate a branch here, and then if we move again and we're getting another chance, we're going to generate the branch here, and if we don't get one here, we don't get one here, then we move here, we're going to get another chance, we're going to generate a branch. So that's what we're basically doing. So in the generate branch function, what we're going to do first is to create another object. Let's call it branch, and we'll give it a property x, which will be the current x, and a property y, which will be the current y. And then we're also going to give it a length, which will be the same, get a random integer between the current y value plus, let's say, maybe 100, and the current y value plus 300. So we are going to get a bolt with a length of maybe 100, or a bolt or a branch of maybe length 300. All of these values can be changed, so you can get a lightning bolt which suit your preferences. And then what we'll do next is we'll create another while loop, we'll create another while loop. While branch.y is less than branch.length, we are going to do the same thing we did for the bolt. So branch.x plus equal to a random integer. Maybe let's say, maybe instead of maybe -10 this time, we'll maybe make it 5, and then it's supposed to be a semicolon. Then we'll do this branch.y plus equal to get a random integer, maybe let's say again from maybe 2 and 20. So we're going to add a random value between 2 and 20 to the branch's y position, and then we're going to add a -5 or 5 to the branch's current x position. It's basically the same thing we did here. Then once we do that, we're going to move to trace a line to pen.line to branch.x branch.y, and then we will move the pen back to the original position it was in the bolt. So pen.move to branch x, y. So we are drawing the lightning bolt, we get a branch, and then we draw the branch and we move the pen back to this position so that we can continue. We get a branch, we draw the branch, then we move the pen back to this position. So that's what we're going to do, and we should have working branches. We should be having working branches, and yeah, you can see we have the branches. So now once we have this, we can maybe make branches of branches, but I'll leave that up to you. you can make this branch into more branches like this. Get a branch, get another branch, then maybe get another smaller branch, then you move the pen here, then you move, but don't make it move infinitely because your PC might hang. But yeah, I'll leave that up to you. So once we have that, we're going to make the bolt flicker. And how we're going to do that is, let's create a function and we'll call it generate random lightning or animate or whatever you're going to call it, random lightning. And in this function, we're going to move this up here, and then we are going to call the outer wrapping function generate random lightning. And in this function, we will set a timeout of random. We'll set a timeout of. Let's move it. Let's move the generate lightning function into the timeout, and we're going to generate a random function between a random integer. Let's say between maybe like 100 and 100 milliseconds. No, let's make it 1 second or 3 seconds, so we can have a lightning bolt every 1 second or every 3 seconds. So once we call that, then once we set the timeout, we're going to call the same function again, generate random lightning. So we are going to call the function the first time. It will set a timeout, and after 1 or 3 seconds, it's going to generate a lightning bolt, and then it's going to call this function. It's going to call itself again, and then it's going to set another timeout, then generate the lightning bolt. So you can see that we are getting lightning bolts, but they're sort of being multiple at the same times. So we can fix that, and how we'll fix that is every time we generate a lightning bolt, we are going to say pen.clearRect. We're going to clear the entire screen, 0, 0, canvas.width, canvas.height. So we're clearing a rectangle from point 0, 0 to the we're clearing a rectangle from point 0 to the canvas's width, canvas's height. So everything in between this rectangle will be deleted. So now we'll have a bolt, then the bolt disappears and another bolt is produced, then that bolt disappears, and then that bolt disappears, then that one disappears, and we get a different one. But we want to make this more dramatic, how they usually look like in real life. So once we generate the bolt, let's give this generate lightning function a counter, and let's make it maybe 0. And then let's move down here. So if, let's give it a condition, if counter is less than, let's say like 8, we're going to produce 8 different lightning bolts. Generate lightning, generate lightning, and then we're going to give it the current X position so that we get a 8 lightning bolts at the same position. So we're going to give it X, and then we're going to pass in counter plus 1. Then we'll move back here and pass in the current X value, X. Let's give it X, and let's set it to null at the beginning. So we'll generate a lightning at a point, and then before we create the next lightning bolt, we'll check if, we'll use a shorthand if. So if X is null, then we'll generate a random X value for the lightning bolt. But if X is not null, we'll set it as X. We'll set the beginning position of the, oh, that was a mistake. This should be the question mark. It's a shorthand if, you can look it up, or I might make a function tutorial about it. So stick for it. So if X is null, Then we will set the value of the beginning x position of the lightning bolt as a random integer, or if it's not null, we'll set it as the given x value here. So when we generate the next lightning bolt, we'll pass in our let's move here, and then let's create another constant. Actually, let's call it root x. Let's create another constant. We call it root x, which will be equal to the lightning's beginning x position. So when we generate the next lightning bolt, we're going to pass in root x so that it starts at the same position as the first lightning bolt. So if counter is less than 8, then generate another lightning bolt. So with this, we should get 8 different lightning bolts. So there is an issue. So yeah, the issue is this. We're generating a lightning bolt too fast for us to see. So we should set a timeout. We should set a timeout for maybe let's say like 100 milliseconds, and then we're setting another timeout, and this should work. It's not working. Why? Yes, there we go. It's working. Oh, the issue was the initial delay. So now we're getting lightning bolts and they're moving, but let's make it a bit faster. Let's change this maybe to 50 milliseconds. So we'll wait a bit, then we get the lightning bolt. Yeah, it's working fine. It's working very fine. So let's set this also. If the last lightning bolt has been produced, then we're going to set another timeout for maybe like 100 milliseconds, and then we're going to clear the screen again so that the last lightning bolt doesn't stay on the screen. So we'll copy that here, and then we'll set this maybe to like 100 milliseconds, and then let's set this maybe to, so that it doesn't really take like 1 second to start, let's set this to like 100 milliseconds to 3 seconds, or let's set this to 2 so that we can see the simulation more perfectly. 100 milliseconds to 1 second, or let's say 2 seconds. So once we run this, we can see we have the lightning bolt. It appears then disappears. Now let's set this to a little bit larger value, like 200, and then let's set this to like 500. I don't really want them to overlap. So now we have our working lightning bolt. We have a working lightning bolt. Yeah, so that's how you make lightning bolt with JavaScript. If you like this tutorial, consider subscribing, and you can leave links to any projects that you've made with this in the comments. And yeah, please like, subscribe, and follow for more.